we are going to discuss again some important parts of matrices. That's nothing but elementary operations of matrices. As I have said in my previous video that we'll be getting to learn this in my next video. So starting with this, that what are elementary operations of a matrix? Mind you, elementary operations are also called as transformations because elements are transformed in this, so they are called as transformation. And why they are called elementary operation? Because they are directly related to elements of the matrix, so they are called as elementary operations of a matrix. And totally there are six elementary operations. Out of those six, three we have due to columns and three we have due to rows. Starting with the first rule, that is nothing but the interchange of any two rows or two columns. In this, any two rows or two columns are being interchanged. Starting with this one, interchange of ith and jth rows, it is denoted by ri tends to rj. It means that row ith row tends to become jth row. So interchange of ith row and jth row, I becomes j and j becomes I. This ith row becomes the jth row and jth row becomes the ith row. Next, what it says, that interchange of ith and jth columns, same as here rows are exchanged, here columns will be exchanged as in the values of I and j. So here we have an example to get the clarification about that. The first matrix we have A of the order 3 by 3. By applying row 1 tends to row 2, as the line here says that ri tends to rj, so row 1 tends to row 2, means I is equals to 1 and j is equals to 2. From here we can say I and j, we can say I is equals to 1 and j is equals to 2. So row 1 tends to row 2, means row 1 wants to become row 2 and row 2 wants to become row 1. So we have double-sided array here. Double-sided array shows that both the sides elements, both the sides things are getting interchanged. So we can say row 2 is trying to become row 1 and row 1 is trying to become row 2. So we can say here this is the first row 1 2 3, which becomes second row here 1 2 3, and this is the second row 4 5 6, which becomes first row here 1 4 5 6. So row 1 and row 2 are exchanged and the obtained matrix is same, nothing else. Same applying here in the column wise, we can say that C1 tends to C2, means column 1 wants to become column 2 and column 2 wants to become column 1. So we have column 1 here, this one 1 4 7, so that becomes column 2 here. By operation this, we can say we see here 1 4 7 as the column 2, and same column 2 becomes column 1. So column 2 we have 2 5 8 here, which becomes column 1 here, that is 2 5 8. So now I think you are clear about this rule. The rule that says that interchange of any two or rows or two columns. Now the second rule says that the multiplication of elements of any row or column by a non-zero number, means elements are being multiplied by a non-zero number, because if you multiply any element by 0, then the resultant will be only 0. So it says that we must multiply any element of all the elements of any row or any column by a non-zero. Non-zero includes any integer, might be negative or positive, let it be negative or positive, but not 0. Excluding 0, it can be any negative, any integer. So the rule says here that multiplication of each element of ith row by k a constant value, as it says here, that it is said here that non-zero number, so it can be k, where k is not equals to 0, means non-zero, k is not equals to 0, and it is denoted by ri tends to kri, means k is multiplied to row I, elements of row I. So if we apply column wise, then rule says that multiplication of jth column by k. Jth column means elements of jth column. As said here, it should not be equals to 0, since it is a non-zero, and it is denoted by cj tends to kcj, means j, there will be some values of j here, so jth column is multiplied by k, so we can say cj tends to kcj. As in, we can see in the example that the matrix B of order 2 by 2, after applying the operation row 1 tends to half of row 2, as the rule says here ri tends to kri, means row 1 tends to half of row 2, k we have k is equals to half. Then we can see that row 1 tends to half of row 2, means row 1 we have 2 and 4. So the first element, if you see 2, means half of 2 is row 1 tends to half of row 2, we have 3 here, and same applies for this also, that 4, so it becomes 4 here. By applying this column, column 1 tends to half of column 2. Column 1 is this one, no, this is the column 1. that is 10 and 8. So first element we have, mind you my friends, here is a small mistake. It should be 10 by 2 means it should be 5, and 8 by 2 means it should be 4, not 1 by 2 and 1. So sorry for it, we should be having here 5, and here we should be having 4. Sorry for it, but applying the operation c1 tends to half of c2, as half as constant k, we get here 5 and here 4, and this one 1 and 2 will be the same. So next in the line we have another rule, that is the addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by any non-zero number. It means to say that we add after we multiply some column or row of elements by some constant, we add them. How we add them? That is, after this we'll be getting the example how we add them. First we should learn this, that is the addition of ith row, the corresponding elements of jth row multiplied by k is denoted by ri tends to ri plus krj. As it says here, the addition of elements of any row or column means we add here ri plus krj. After multiplying krj we can add. So this elementary operation, it is allowed here, that in order to change ri we can do this operation, and if we apply it column wise, then we can see that this one we have the corresponding column operation is denoted by ci tends to ci plus kcj. To get the clear picture of this operation, as it is not very clear in the definition, we have an example to make it clear. So we have matrix C, order of 2 by 2, it's a square matrix, and applying the operation row 2 tends to row 2 minus twice of row 1. That is, after applying this operation means, get it clearly, we will see it for one element only. So row 2 tends to row 2 minus twice of row 1. Row 2 is this one, down one, row 2. This tends to become what? This tends to become row 2 minus twice of row 1. So from this we will be subtracting twice of this. So 2 minus twice of 1. So 2 minus 2. 2 minus 2 we get here 0. So we have 0 here. And minus 1 if we see here, then minus 1 minus 1 minus 4, minus 1 minus 4 we have minus 5. So now I think it is clear, very clear to you, that how this operation takes place in the following matrix. So we get this here as resultant, and if you apply it in a column wise, then we say that column 2 tends to column 2 minus twice of column 1. What is column 2 here? Column 2 is this one, and this is the column 1. So column 2 tends to become column 2 minus twice of column 1, means from this column 1 twice of column 1 is subtracted. This from this column 2 twice of column 1 is subtracted. So first element 2 minus twice of c1 means 1 into 2 minus 2, so we have 0 here. And same for this also, 1 means 1 minus twice of column 1, so 1 minus 4 we have minus 3. So now I think it is very clear to you that how this operation takes place in column wise manner. So with this, hoping that